Compound interest, making your money grow faster. You might have heard of simple interest, where interest is calculated only on your original deposit. But what if you could earn interest on both your deposit and the interest you've already earned? With compound interest, savings grow and produce more interest over time. Let's work through an example. Lucy wants to put some money in the bank in order to earn interest. She deposits £200 into her savings account where she can earn 2% interest per year. She wants to see how much her money will grow if she leaves it there for 3 years. With this knowledge, we're going to answer the following 2 questions. 1. How much money in total is in her account at the end of the 3 years? 2. How much interest has she made at the end of the 3 years? With compound interest, the bank pays 2% interest on both the original £100 and any interest that Lucy earns. We'll start by calculating the amount of money in Lucy's account after 1 year. We can use a multiplier to do this, which converts a percentage into a decimal. We start with the deposit, which is 100% of the money in her account. To get a decimal, we divide by 100, which gives us 1. We want to increase this amount by a percentage, i.e. the interest earned, in this case by 2%, which divided by 100 is 0.02. This gives us 102%, or 1.02, which represents our initial deposit plus the interest. So we take our multiplier, 1.02, and times this by Lucy's initial deposit of £200, which gives us £204 after the first year. As Lucy also earns interest in the second year, we need to repeat this process, but instead of timesing the multiplier by £200, we need to multiply by £204, as this is the new amount in her account after earning interest in the first year. As we can see, at the end of the second year, Lucy now has £208 and 8 pence in her account. For the third and final year, we repeat the process, making sure to multiply the new amount in her account, £208 and 8 pence, by the multiplier, 1.02. So after 3 years, Lucy will have £212 24 pence in her account. Note that we rounded our answer to 2 decimal places as we are dealing with a monetary value. From here, we can work out how much interest Lucy has earned. We do this by calculating the difference between the amount she ends up with after 3 years with the amount she deposited at the start. Lucy earned £12 and 24 pence in interest over the 3 years. You might have noticed from our calculations previously that Lucy earned £4 in interest in year 1, £4 and 8 pence in year 2, and £4 and 16 pence in year 3, to make up the total of £12 and 24 pence. This is the key aspect of compound interest. The amount of interest that is gained grows over time as new interest is earned on top of interest that was previously earned. Now, over to you. Lucy shops around to find another savings account that offers her a higher interest rate of 4%. She decides to deposit £200. Pause the video and work out how much will be in her account after 3 years and how much interest she has earned. Let's start by working out the multiplier. The deposit is 100% of the money in her account. To get a decimal, we divide by 100, which gives us 1. We now want to increase this amount by 4%, which, divided by 100, is 0.04. This gives us 104%, or 1.04, which represents our initial deposit plus the interest. If you added 104, then divided by 100, you'd also get the same answer. Like the example before, to work out the value of her account in year 1, we need to multiply the initial deposit, £200, by the multiplier that we just found, 1.04. This gives us £208. £208 becomes our starting value for year 2, and when multiplied by our multiplier, we get £216.32. Repeating this process to find the final value in her account in year 3, £216.32 multiplied by our multiplier, 1.04, leaves Lucy with £224.97 at the end of the 3 years. We can now work out how much interest Lucy has earned. We do this by calculating the difference between the amount she ends up with after 3 years with the amount she deposited at the start. So, Lucy earned £24.97 in interest over the 3 years. Let's look at how the change in interest rate impacted the interest earned in Lucy's 2 savings accounts. By doubling the rate of interest that Lucy earned, she more than doubled the amount of money that was added to her account in interest over the 3 years. What happens if Lucy saves her money for longer? If we continue the calculations that we have done in this video, we'll see that the effects of compound interest grow over time. In the savings account that pays 2% interest yearly, Lucy will earn £43.80 over 10 years, but £97.19 over 20 years. The effect is even larger in her account that pays 4% interest. After 10 years, she'll receive £96.05 in interest and a massive £238.22 over 20 years. This effect will grow larger and larger over time as interest that has been gained earns further interest. At some point, if no withdrawals are made from the account and the interest rate is high enough, the interest earned each year could be greater than the initial deposit. Let's quickly recap what we've learned. Compound interest is calculated not only on your original deposit, but also on the interest earned. This means your money grows faster over time compared to simple interest. The more time you leave your money in an account earning compound interest, the more it will grow. Even small differences in the interest rate or how long you save can have a big impact on your final total. Remember, banks pay you interest for keeping your money with them. This interest can be seen as additional income. When opening accounts, compare the rate of interest offered by different banks. Interest adds up more and more over time, as long as you keep the money in your bank account.